Hello viewers, you're welcome back. So here we'll be looking at half angle formulas and the application. So how do we derive these half angle formulas? We can derive it. We can derive this from what we already know. Just like before, we already saw that we can write cosine 2 alpha as 1 minus 2 sine squared alpha, right? So now let's make things a little bit different. So you can see this is where you have 2 alpha and this is alpha. So, but I'm interested in what? In alpha over 2. So what we are going to do is, it means we can write this. Where do I want alpha over 2? So in the place of alpha, let's write alpha over 2. So it will become sine squared alpha over 2, right? So once I do that, it means on the right-hand side, I cannot write 2 alpha again, because if you look at this here, here we have alpha, here is 2 alpha. So if we change alpha to alpha over 2, you see, then also we need to change the angle here. The angle here is going to change, which is just going to be 2 times alpha over 2. And that will be just what? That will be just alpha. So here is going to be cosine alpha, see? Then we can try to make, sine alpha the formula, right? We can solve for it. So here, let's rewrite things here. So let's bring this here. So this is 2 sine squared alpha over 2 is going to be 1 minus what? Cosine of alpha. See that? Then we can solve for sine squared. So sine squared alpha over 2, it's simply 1 minus cosine alpha divided by 2. And then we can solve for sine alpha over 2, which is going to be plus minus root of 1 minus cosine alpha over 2. So this is what we call the half angle formula for sine, right? So in the same way, we can solve for cosine. For cosine, what do? The same story. We know that what? The double angle formula for cosine 2 alpha, if you remember, is the same thing as 2 cosine squared alpha minus 1. So also we should observe this one. Just like I said the other time, if you see here, we have alpha. Here is what? 2 alpha. So now let's change it to what? Let's change it now to cosine. Here definitely will be alpha. And here is going to be what? Cosine squared alpha over 2 minus 1. So the same double. So if this is alpha over 2, this is just going to be alpha as well. All right. So now we are going to solve just like here. We solve for the sine squared of alpha. Here we are going to solve for what? Cosine squared. So it means we can leave this and write cosine alpha plus 1 is the same thing as 2 cosine squared alpha over 2. So let me just rewrite it. Take this, nothing has changed. I can do this one. And this is cosine squared plus, cosine alpha plus 1 is the same thing as 1 plus cosine alpha. Nothing changed. I just interchange the places. So it means that cosine squared alpha over 2 is equals to 1 plus cosine alpha divided by what? Divided by 2. Yep. Now, this means that what? Cosine alpha over 2 is going to be plus minus root of 1 plus cosine alpha divided by 2. So this is the formula for this one. And this is the formula for the half angle. Now, one thing you need to take note of the difference is just that this one, you see here is what's here, it's negative, while here it's what is positive. That is just the difference. Okay, now let's talk about that of what's that of tan. Right. So now we're on to the half angle formula for tan. So here we're going to have various this lengthy discussion maybe. Now let's look at this. What is tan alpha over 2? Tan alpha over 2 we know is going to be sine what? Alpha over 2 over what? Cosine alpha over 2. Yes. But what is this one? This is just plus minus 1 minus cosine alpha over 2, right? Then divide by the same thing, which is plus minus. We have 1 plus cosine alpha all over 2. So this is what we have when you try to use the earlier results. But this is still not just going to be, it's just going to be plus minus, right? You can divide. If you put them under one root, we will be left with 1 minus cosine alpha over what's 1 plus cosine alpha, right? So at this stage, you have two options. You can rationalize by the denominator. 2 will cancel 2, if you can see, because of the division. So we can rationalize by the conjugate of the denominator or the conjugate of the denominator. So we have two cases. So let's deal with the first case, which will say case 1, rationalize with what? With the conjugates of what? The denominator. So in that case, we will have tan alpha over 2, it's equals to plus minus 1 minus cosine alpha, 1 plus cosine alpha. So we will multiply by 1 minus cosine alpha over 1 minus cosine alpha, you see? All right, so now we will have tan alpha over 2 is equals to plus minus. If you look at the top, you will just have 1 minus cosine alpha all squared over what? You have 1 minus 1 squared minus cosine squared alpha. Okay. Then we can split the powers here. So this will be plus minus root of 1 minus cosine alpha squared over here also we can split, right? We can split the denominator, which is 1 minus cosine squared alpha. Now, this is just going to be plus minus. This is going to be absolute value of 1 minus cosine alpha, right? Over this denominator here. If you look at this denominator, we can write it as what? Sine squared alpha, right? Because 1 minus cosine squared is the same thing as sine squared. So, which we can also write in terms of absolute value. This is 1 minus cosine alpha all over the absolute value of sine alpha. Yes. But what do we know about cosine? We know that the cosine, the maximum value of cosine is what? Is 1. So this is going to be always positive, right? Or negative. So it means we can remove the absolute value because cosine alpha can never be greater than 1. Yes, this can never be greater than 1. The maximum value of cosine alpha is always 1. It means what is inside the absolute value is always positive, right? Or 0. So it means we can remove it. So you have plus minus, then you have 1 minus what? Cosine alpha divided by absolute value of sine alpha. But for sine alpha, we really don't know what sine alpha will be, whether it's going to be positive or negative, depending on alpha. But if you look carefully, anytime. All right. So now what we need to justify is the sine of tan alpha over 2. So do we need to keep this plus minus? So what this simply means is that tan alpha over 2, it could be plus, it could be minus. Now, depending on the sign of what? Of sine alpha, because we need to be able to remove the absolute value. But we know that the sine of alpha will depend on what is alpha over 2. So let's check. Let's have a table of this. Now let's say we have alpha over 2. If we have alpha over 2, then let's talk about tan alpha over 2. And we need to know also what is alpha. And then we need to know what is sine of what? Sine of alpha. So then we need to know what is going to be this expression, which is plus minus 1 minus alpha over absolute value of sine alpha. All right. So for example, now, if alpha over 2 is in the first quadrant, it means it's between 0. So let's say alpha over 2 is between 0 and 90. So which means you are in the first quadrant, right? So if it's in the first quadrant, definitely we know that tan alpha over 2 is going to be positive, right? And what is sine alpha? Sine alpha itself is going to be between 0 and 180, right? And that means you are either in the first or in the second. Alpha is either in the first or in the second quadrant. So if alpha is in the first or second quadrant, we know that sine is also positive. So if sine is positive, it means that what? The absolute value of sine is going to be positive. So this is going to be positive, right? So if this is positive, then what are we left with? I'm sorry, here should be cosine alpha, I mean here. So you can see that what? This sine and this sine are always what? Are always the same, yes. So what I mean is that what? You can see that the absolute value of sine alpha is going to be positive. So it means that for the sine of tan alpha over 2 to be positive, it means that what is the absolute value of sine alpha is also positive. So it means that we're just going to have the same sign. Both the numerator and denominator will be positive, both positive, right? So, but let's see the other cases when you are between, let's say 90 and what? And 180. In this case, you see that tan alpha over 2 is either in the what? It's going to be in the second quadrant. So in the second quadrant, this is going to be negative, right? Tan alpha over 2 will be negative. But alpha itself is going to be between 180 and what? It's just going to be, you multiply by 2. So it's going to be between 180 and 360, right? Now, if you are between 180 and 360, you see that you are either in the what? In the second No, now it's going to be in the third or in the fourth quadrant. But in the third or fourth quadrant, we know that sine is negative. Yes. So if you look at it, what will happen? If sine is negative, remember, tan alpha over 2 is already negative, yes? So it means, and the absolute value of sine alpha is going to be negative, yes? So it means you will have negative canceling negative, because this, you will have negative here, and you have to bring negative outside, which will cancel the negative coming from tan alpha over 2. So it means that this is going to be negative. So in other words, the negative here will cancel the one coming from the numerator. Now, thirdly, you can have alpha over 2 to be from where? Alpha be between 180 and let's say 270. So this one, remember, this is the position of what? Alpha over 2, 270. So in that case, you will have what? You will have tan alpha to be what? Because this will be quadrant what? This is quadrant 2, and this will be quadrant 3, right? So tan is going to be, tan alpha over 2 is going to be positive, because you're in the third quadrant. This is second quadrant. So if you multiply both by 2, you will have that this is going to be 360 is less than alpha is less than what? 540. So you can see that alpha is going to be between 180, sorry, between 360 and 540. That is where we have alpha. And for you to know the quadrant, you can see that 540 is already bigger than 360. You can take the coterminal. If you subtract 360, this means 0 less than alpha less than what? 360, right? This is less than 180, because 540 minus 360. So you can see that this is simply telling us 0 to 180 is either in the first or in the second quadrant. But in the first or the second quadrant, sine alpha is going to be positive, which means that what? The absolute value of this is going to be positive, right? So if the sine of tan alpha over 2 is positive and the absolute value of sine is also positive, it means the result is going to be positive. And finally, we look at when you are between 270 and what? 360. So it means that now you are in the fourth quadrant. It means alpha over 2 is in the fourth quadrant. So if alpha over 2 is in the fourth quadrant, tan alpha over 2, we know it's going to be what? Tan is negative in the fourth quadrant. So this is negative in the fourth quadrant. Okay, so let me take this down a little. So here I said when you are between 270, alpha over 2 is 3. So it means you are in the fourth quadrant. So tan is going to be negative. Now, if you multiply this by 2, what do we get? You will see that here you will have 4 and what? 720, right? And 720, yes. And now what can you do? And so this is telling us you are in what? In the fourth quadrant. And here you can also do what? You can also do the quadrant thing or the coterminal. This is just going to be between you subtract 360, right? So here, if you subtract 360 to both sides, this is going to be 180 less than alpha less than 360. which means that this will be either in the what? This is going to be so this is going to be either the third or the fourth quadrant. But we know that if you are in the third or the fourth quadrant, sine is what? Sine is negative. So since sine is negative, what will be the sign of absolute value of this? Here, if sine is negative, the absolute value, the sign is going to be what? It's going to be also negative. Yes, because before you remove the absolute value, you need to put what? Minus outside. So this now tells us that what? The signs actually depends on what? The sine of alpha over 2, tan alpha over 2 is going to be the same as what? This absolute value. So we can remove this sign, plus minus is not required, and we can remove the plus minus and also remove the absolute value. So this is just going to be 1 minus cosine alpha over 1 minus what? Minus sine alpha, because the signs will always cancel out. As you can see here, this is plus, this is plus. So let's see the plus, they're all the same. And the minus are also the same. Okay, so this is it. All right. Now let's take the second case. What is the second case? The second case is the case when you rationalize by what? By the conjugate of the, look at here, you know, we have two cases. Here, the first case is that we rationalize with the conjugate of the denominator. So if you remember, this is where we got to, and then we started rationalizing. So this is tan alpha over 2, right? So just to finish, we will now rationalize this. So let's take case 2. So case 2, if you remember, this is where we're coming from. It was plus minus. Then we had the sign, which is 1 minus tin cos alpha, right? And then we have 1 plus cos alpha. So case 2 is now we rationalize with what? With the conjugates of the numerator. So this is going to be 1 minus cosine alpha, 1 plus cosine alpha. We multiply with the conjugate of the numerator. What is the numerator? The numerator is 1 minus cos x, so the conjugate will be 1 plus cosine alpha, also 1 plus cosine of alpha. And if you move both sides, if you multiply what you have at the top, you will have just 1 minus cosine squared alpha. The denominator, you will have 1 plus what? Cosine alpha, all squared. And now this you can rewrite as what? 1 minus cosine squared is what? Is sine squared alpha over 1 plus cosine alpha all squared. So here we can take the roots. Now you can separate the roots so that you have sine squared alpha over 1 plus cosine alpha all squared. Right. And now you can see that the numerator is going to be plus minus absolute value of sine alpha over This is just going to be absolute value of what's of 1 plus cosine alpha, right? But we know that the denominator is going to be always positive, right? Because 1 plus cosine alpha is always going to be positive, because the smallest it can be, the smallest cos alpha can be is what? Is -1, yes? So this, we don't have issue with the denominator. So we can remove the absolute value. So we have tan alpha over 2 is equals to plus or minus. We'll have absolute value of sine alpha over 1 plus cosine of alpha, right? And then using the analysis we did. Now here, why did I remove the absolute value for the denominator? Because we know that cosine alpha is always between what? This is what we know. -1 is less than what? Equals to cosine alpha is less than equals to 1. This is always true. Yes. Now, if you add 1 to every side, if you add 1 here, -1 plus 1 is 0. So you add 1 to all the side of the inequality. So this will become 2, right? So it means that 1 plus cosine alpha is always between what? 0 and 2. So it can never be negative. So since it can never be negative, you can remove the absolute value, right? Okay, so that is why we remove the absolute value. But here, to remove this absolute value for sine, you have to do the same analysis as we did above, because it's going to have the same sign depending on also where alpha over 2 is. So we can remove all the absolute value. They are going to have the same sign. So this is just going to be sine alpha over 1 plus what? Cosine alpha. So this is the second formula. Right, so we have two formula for half angle formula for tan. So it's either you use this or the earlier one, which is okay. All right, so what is the first one? If you look at the earlier one, is this, we have it proved here, this one. So it's either use 1 minus cos alpha. So here, what did I do here? This is just to be alpha. That's, this is just sine alpha. Sine alpha. So we have two formulas. Either this one, 1 minus cos alpha over sine alpha, or the second one, which is sine alpha over 1 plus cos alpha. So any one we used is correct. But now you can see the sign. You say choosing your sign depends on what? The plus or minus, depending on the quadrant of alpha over 2. This is very important. All right, so in our next video, thank you for watching. In our next video, we'll be looking at the applications, how we can use these formulas to solve some problems. Thank you for watching.